Have you ever solved a domain question perfectly, only to discover later that the answer was wrong because of one hidden restriction? That's exactly what JEE loves to test. Most students know the basic rules for square roots, functions, fraction functions, and logarithmic functions. But when functions are combined, inverted, or defined piecewise, those basic rules are no longer enough. In this video, you will learn how to think about advanced functions logically instead of memorizing tricks. Once you understand the reasoning, domain and range questions become much easier. Think of this video as 3 levels of increasing difficulty. Level 1 is composite functions, level 2 is inverse functions, and level 3 is piecewise functions. Each level introduces a new way of thinking about domain and range. By the end of this lesson, you will start seeing functions as machines that transform inputs into outputs, and that viewpoint makes JEE questions far easier. Let's begin with the composite functions. A composite function is simply a function inside another function. Imagine two machines placed one after the another. The first machine g of x produces an output. That output becomes the input of the second machine f of x. Now ask yourself this question: what happens if the first machine produces something that the second machine refuses to accept? The entire process breaks. That's why every composite function has two conditions. The inner function must exist and its output must be acceptable to the outer function. This is the most important idea of this chapter. Let's solve a typical JEE style question before doing any calculations. Observe the outer function carefully. It is a square root, and square roots are very selective. They refuse to accept negative inputs. So even before solving the problem, we already know where the major restriction is likely to come from. Let's start with the inner function. Since it is a fraction, the denominator can never become 0. Therefore, x cannot be equal to 2. Many students stop here and think they are done. But this restriction only ensures that the first machine works. We still need to check whether the second machine accepts the output. Now comes the real thinking. Notice that the square root does not care about x directly. It only sees whatever g of x produces. So instead of asking when is x valid, ask a better question. When does the output of g becomes a valued input for the square root? Since the square root requires a non-negative input, we impose that condition on g of x. This transforms the domain problem into inequality problem. After the sign analysis, the inequality is satisfied only between 2 and 3. Notice how both restrictions worked together. The fraction removed x equals 2. The square root restricted everything else. Whenever you see composite functions, remember this mental picture. The inner machine must exist. The outer machine must accept the output. Miss either one and the answer is wrong. Now let's move to inverse functions. This process becomes extremely easy once you understand one key idea. An inverse function simply reverses a process. If the original function converts inputs into outputs, the inverse converts those outputs back into inputs. That's why the domain and range exchange their roles. This is not a formula to memorize. It is a direct consequence of reversing the entire process. Let's solve one example where we have to find the range of the rational function. Many students start guessing outputs or drawing rough graphs, but there is a more elegant approach. Instead of asking what outputs are possible, ask this question: for which values of y can this equation be solved? That single question unlocks the entire problem. Now we solve for x. Everything works smoothly until we reach the denominator. If y becomes 1, the denominator becomes 0, and suddenly x stops existing. This is the breakthrough moment. Any value of y that prevents x from existing must be removed from the range. Therefore, our range becomes every real number except for 1. Notice that we never graphed the function. We never tested random values. We simply asked whether x could exist. This logical approach works for many JEE range questions involving rational functions. So, the shortcut method is solve for y, find values of y that makes x impossible. Now, let's discuss the category that scares most students: piecewise functions. The most students see multiple formulas, they panic, but piecewise functions actually become easier once you stop treating them as a single function. Instead, think of them as smaller functions living in different regions. Analyze each region separately, then combine the results. Let's find the range systematically. We start with y equals x plus 2. Instead of guessing outputs, convert the x into function of y. That gives x equals to y minus 2. Now apply the restriction given in the function. Since x must be less than 0, replace x by y minus 2. We get y minus 2 less than 0. Therefore, y is less than 2. Can y become infinitely small? Yes, because x can become infinitely negative, so the range of this piece is all real numbers less than 2. Notice the pattern. We didn't use graph, we used algebra and restrictions. This is the same strategy that is used in difficult JEE range problems. Now let's analyze the second piece. We start with y equals x squared. Since x is already restricted to be greater than or equal to 0, we can write x as root y. Now apply the restriction. Root y must be greater than or equal to 0. This happens only when y is greater than or equal to 0. Therefore, every non-negative value belongs to the range. Again, notice the method. Convert x into y, apply restrictions, find the values of y. Now, combine the outputs. The first piece contributes everything below 2. The second piece contributes everything from 0 onwards. Together, they leave no gaps, and therefore the range becomes all real numbers. The key lesson here is not the answer. The key lesson is the process. Analyze each piece separately, then combine. Never do both at the same time. If you remember only one thing from the piecewise functions, remember this strategy. Find range of each piece separately. Respect its domain restrictions. Then take the union. Trying to combine everything at the beginning usually creates confusion and unnecessary algebra. Here is the quick challenge for you. Let's solve the challenge exactly the way a JEE topper would do. Pause the video and try to solve it yourself. Start with the first piece. We have y equals root of x plus 1. To find the range, convert x into a function of y. Squaring both sides gives y squared equals x plus 1 or x equals y squared minus 1. Now use the restriction x less than 3. Replacing x by y squared minus 1 gives y squared minus 1 less than 3. So y squared is less than 4. This gives minus 2 less than y less than 2. But don't stop here. Many students lose marks at this stage. Remember that y came from a square root. A square root can never produce a negative output. Therefore, y must be greater than or equal to 0. Combining both conditions gives 0 less than or equal to y less than 2. Now move to the second piece. We have y equals x minus 2. Rewrite it as x equals y plus 2. Since x is greater than or equal to 3, we get y plus 2 greater than or equal to 3. Therefore, y is greater than or equal to 1. So the second piece contributes all values from 1 onwards. Finally, combine both the intervals. The first gives values from 0 to 2. The second starts from 1 and continues forever. Together they cover every value from 0 onwards. Hence the final range is 0 to infinity. Let's summarize the entire lesson. For composite functions, think like a two-stage machine. For inverse functions, think about reversing a process. And for piecewise functions, think of separate functions living in separate regions. These are not tricks, they are ways of thinking. And correct thinking always beats the memorization. If you master the logic behind it, a huge number of JEE questions become easier. And if you would like part 2 covering logarithmic, trigonometric, modulus and greatest integer functions, let me know in the comment. See you in the next lesson. Please do not forget to like the video and subscribe to my channel for more.